You know, we hear the word average thrown around all the time, right? The average salary, the average temperature. But what if I told you there are actually 3 different kinds of average? And yeah, each one can tell a totally different story. Today, we're going to unpack what they are and, more importantly, how to find them when you're staring at a huge pile of data. Let's get into it.
Okay, so picture this. You've got, 10,000 test scores, just this massive, endless spreadsheet. Your eyes are glazing over just looking at it. How in the world do you take all of that, all that chaos, and boil it down to a single number that actually means something? How do you find the average score? Well, that's exactly the puzzle we're going to solve today.
All right, here's our game plan. First up, we'll tackle what I call the grouped data problem. Then, we're going to build out our statistical toolkit with 3 key tools: the mean, the median, and the mode. And finally, and this is the important part, we'll figure out how to choose the right tool for the job. Sound good?
Okay, first things first. Before we can even think about calculating anything, we've got to deal with the raw data. Our first job is to bring a little bit of order to the chaos, to turn this messy, overwhelming list of numbers into something manageable.
So take a look at this. These are the scores for 30 students. We can kind of see, okay, one person got a 10, 3 people got a 36. But honestly, it's still just a big jumble in numbers, isn't it? If I asked you, so how did the class do overall? It's pretty much impossible to say just by staring at this. There has to be a better way.
And here it is. We group the data into these little buckets, or what statisticians call class intervals. Now look at that. Instantly you can see that 7 students scored somewhere between 40 and 55. So much cleaner, right? But in making it simpler, we've actually created a new puzzle for ourselves. We've lost the exact scores. Did those 7 students get 41s or maybe 54s? We just don't know anymore. And figuring out how to deal with that missing info is the key to finding our average.
All right, let's grab our first tool from the toolkit. This is the one you probably know and love, the mean. It's the classic average. The best way to think about it is like this. Imagine we took all the points from every single student, threw them into one giant pile, and then divided them up perfectly evenly. The mean is that fair share that each student would get.
So how do we deal with not knowing the exact scores? Well, here's where we get a little clever. We make a really smart assumption. For each of those groups, we just find the exact middle. It's called the class mark, and we just kind of pretend that everyone in that group got that one score. So for that 10 to 25 group, we'll just say they all scored a 17.5. Is it perfect? No, it's an estimate. But it's an estimate that makes the whole calculation possible.
Okay, let's see this in action. This is called the direct method. For each row, it's pretty simple. We just multiply the number of students by their assumed score, that class mark we just talked about. So, 2 students at 17.5 each, that gives us a total of 35 points for that group. We just do that all the way down the table, and then, for the grand finale, we add up that last column to get a total of 1860.
And the last step, super easy. We take that big total, 1860, and we divide it by the total number of students, which was 30. And bam, that gives us our approximate mean score of 62. So what that's telling us is that if all the points were handed out equally, every student would have gotten a 62.
Now you can probably imagine, if these numbers were way bigger, all that multiplication could get, well, pretty tedious. And statisticians, being clever people, have come up with some shortcuts to make the math easier. But here's the thing. They all get you to the same answer. The big idea is always about finding that one fair share value.
Okay, so the mean gives us the balance point of the data. But what happens if you have some really extreme scores? Like what if one student got a 0 and another got a perfect 100? Those outliers can really pull the mean around. It's like calculating the average income in a room with 9 normal people and 1 billionaire. The mean would be crazy high and not really representative. So if we want to find the person who is literally in the middle of the pack, ignoring those extremes, we need a different tool, and that tool is the median.
So to find this middle student, we need to add a new column to our table. It sounds fancy, cumulative, frequency, but honestly, it's just a running total. It's super simple. You start with the 2 students in the first group, then you add the 3 from the next group, so now you know 5 students scored below 40, then add the next 7, and so on. This running tally makes it incredibly easy to find where that middle person is hiding in our data.
Finding the median with group data is a nice, clean 3-step dance. First, you figure out where the halfway point is in your line of students. Second, you use that cool cumulative frequency column to find which group, or class, that middle person falls into. And third, you use a special formula to kind of zoom in and pinpoint their exact estimated score inside that group. Let's take an example with 53 students. The middle spot would be student number 26.5. Looking at our running total, we can see that person is sitting in the 60 to 70 score group. We then plug that into our formula, and it tells us their estimated score is 66.4. Now, that's the really important part. It means that exactly half the class scored below 66.4 and the other half scored above it. It's the true center line of the data.
All right, time for our final tool. And honestly, this one's probably the easiest to wrap your head around: the mode. With the mode, we forget all about balance points and middle values. The mode cares about one thing and one thing only. What was the single most popular, most frequent thing to happen in the whole dataset?
Now, with our grouped data, we can't see the single most common score anymore, right? But what we can see is the most popular group. We call this the modal class. So once we spot that group with the most people in it, we use another formula to estimate what the single most common score was inside that popular group.
So if we look back at our student data, we can spot the winner right away. That 40 to 55 group had 7 students more than any other. So that's our modal class. We run the numbers through the formula, and it tells us the estimated mode is 52. So what this suggests is that a score of 52 was probably the single most common score in the entire class. Okay, so now we've got our 3 tools: the mean, the median, and the mode. The big question is, which one is the best one? And the answer is, well, it's not that simple. It completely depends on what question you're trying to answer, what story you're trying to pull out of the numbers. Let's really break this down. Think of it like this. The mean is your workhorse. It's great for getting an overall picture, but you gotta be careful. Those really high or low numbers can pull it way off course. The median? That's your hero when you have those extreme values. It just finds the true middle and ignores the noise. And the mode? Well, the mode is all about popularity. It's perfect for when you need to know what's the most common choice, like what's the most popular t-shirt size you should sell. So let's bring this home with our student data. Remember, the mean was 62, but the mode was 52. See? Those are 2 very different numbers, telling 2 totally different but equally true stories. One says the fair share score was 62. The other says the most common score was 52. Neither one is wrong, they just answer different questions.
Okay, so let's do a quick recap of the big takeaways. We know how to take a huge mess of data and organize it into groups. We know the mean is the balance point, the median is the true middle, and the mode is the most popular kid in class. And most importantly, we know that picking the right tool for the job all comes down to the question you're asking.
So I'm going to leave you with a little challenge. The next time you're reading an article or you see a report that mentions an average salary or an average home price, just stop for a second and ask yourself, wait a minute, which average are they talking about? Is it the mean, the median, the mode? Because now you know the answer to that question can completely change the story.